Hello, you guys. We are going to be starting our new chapter, which is going to be chapter 9. This is usually one that I save for the very end of the school year, and I'm at this point not really sure if we're going to do another chapter after this, so it very well could be our last one. As you'll see, the notes are a little bit different. I don't really like the notes that go with the set of notes that we usually do for chapter 9. So I'm going to use these instead because I think especially with us being apart, it'll really help to have more examples and have things spelled out a little bit more clearly. So all that being said, as you'll notice, I already have some things filled out, and that's just to save a little bit of time so you don't have to watch me write it, because I am using a new tool and it sometimes lags a little bit. So let's start with the fact that this whole chapter is about transformations, and basically we're going to be doing reflections, dilations, translations, and what's the other one? Rotations. And so we're going to start off with just the basic definition of what a transformation is. And a transformation is an operation that maps an original figure, which is called the pre-image, onto a new figure that we call the image. So sometimes that confuses people. The pre-image is actually the original image that you start with, and then the new image that you get after you do your transformation is called your new is your new figure, and it's called the image. So you have the pre-image and then you have the image. You're going to hear me say new image a lot for your new figure just to help you clarify a little bit. Then a transformation can change the size, it can change the position, or it can change the orientation. However, it cannot change the shape of whatever you're dealing with. Okay, even when we do dilations, which do change the size, they never change the shape. So our shape is still going to look the same. It's just, it could be sitting in a different direction, it could be flipped, it could be mirrored, it could be slid to another place on our graph. All of those things could happen. It could be bigger or smaller, but it's never going to change shape. Okay, so we're going to focus on just reflections today, and I think this is an easy one for us to start with. A reflection is a flip of an image across a line called the line of reflection. Each point and its image are going to be the same distance from the line of reflection. So that part right there is really important, and you're going to hear me say that a bunch when we do these notes. The possible lines of reflection that we could use would be the x-axis or the y-axis. We use those a lot. Vertical or horizontal lines in the form of x equals a number or y equals a number. If it's an x equals, that is a vertical line. And if it's a y equals, that's a horizontal line. Or we could use diagonal lines in the form of y equals x or y equals negative x. And I'll show you what those look like later. Okay, so let's start off with problem 1. I already have the original figure drawn that they give you, and we are going to reflect this across the x-axis. So let me grab my line tool here so that it makes a nice straight line. And so we're going to reflect across the x-axis, which is this axis right here. Okay, so what we're looking to do is we basically want to try to reflect this across there. So that means that we're going to be looking at each of these points, A, B, and C, their distance from that yellow line to determine where our new point is going to be. So I'm going to start with A. And A is 2 boxes above the yellow line. So I'm going to go 2 boxes below the yellow line, and that is A prime. And we call it A prime because that is our new image. Okay, so if we start with A, our new image is going to always have a prime after it. C is 1 box above the yellow line, so I'm going to go 1 box below the yellow line, and that's going to be C prime. And then B is going to be 7 boxes above the yellow line, and so we are going to go 7 boxes below the yellow line on that same line that B originally sat on and call it B prime. So let me go back, and now I'm going to connect all my dots. And as you can see, this is a mirror image of the triangle that we started with. And our last step is just to go and write down what our points are. So A prime is -4, -2. B prime is 4, -7. C prime is 5, -1. And then we're finished. Okay, so let's look at the next one. So in the next one, I have the original graph. We are going to be reflecting, actually I meant to do this on the last one. We're going to reflect across the y-axis. So I'm going to highlight that so you guys can all see what I'm talking about. So the y-axis is this line right here. So we're going to be measuring all the distances from that line. So P is 1 box to the right, so I'm going to go 1 box to the left and make that P prime. Q is 2 boxes to the right of that yellow line, so I'm going to stay on the same line, but I'm going to go 2 boxes to the left of the yellow line. R is 8 boxes to the right, so I'm going to go 8 boxes to the left, and there's R prime. And S is 7 boxes to the right of that yellow line, so I'm going to go 7 boxes to the left. And once again, notice we are not changing the line that it's sitting on. We're just going to shift it over to the other side of this picture. And again, it should look like a reflection, a mirror image. Okay, so this is what it'll look like when you're finished. And our points, P prime is -1, 2. Q prime is -2, 5. R prime is -8, 3. And S prime is -7, 0. So a couple things I want to point out really quick. When we are dealing with, let's start with the y-axis since that's what we're talking about. We're dealing with the y-axis. Notice that none of my y values change. Okay, my y values all stay the same. The only thing that changes is that my x values all become negative because I'm flipping over to the negative side of x. Kind of similar with the x-axis from the last one. None of my x values changed. They all stayed the same. My y values all became negative. Okay, so that's not a coincidence. That's pretty common. And that's a pattern that you'll see. So for the next one, we're going to do the y-axis. So once again, we're going to kind of anticipate that my y values are going to stay the same since I'm reflecting across the y-axis like I did last time. And now we're going to plot those points. So once again, G is 2 units to the left of the yellow line. So I'm going to go 2 units to the right on that same y value and make my new point. F is 1, 2, looks like 5 units to the left. So I'm going to go 5 units to the right, and there's F prime. And I is 8 units to the left, so I'm going to go 8 units to the right. Now the thing about H is that since it's sitting on my line of reflection, I am not going to move it. So if you ever have a point that sits right on your line of reflection, it doesn't change. It's going to stay in the same place. Because if I were to reflect that, it's going to end up exactly on that line just like it did before because it's 0 units away from that line. So since it's on it, it's going to stay on it. Now I'm just going to connect all those dots. And I have this trapezoid. Okay. And as far, oh, sorry, my pen shut off. As far as the points go, F prime is 5, -2. G prime is 2, -2. H prime is 0, -6. And I prime is 8, -6. And once again, all those y values, you'll notice they're exactly the same as they were up here. Okay, the -2, the -2, -6, -8, none of those changed. All my x values now changed to signs, except for 0, because 0 doesn't have a sign, so it just stayed the same. All right, so let's do one more of these axis problems before we cover some of the other ones. So we're going to reflect across the x-axis, so we're going to go back to the first type that we did. Let me highlight the x-axis for you guys. So we are reflecting across that yellow line right there. Okay, so I'm going to start with X just because it's the closest. So X is 2 units below that yellow line. So I'm going to go 2 units above and make X prime. W is 4 units below. So I'm going to go 4 units above. And my pen shut off. Okay. And there's W prime. Okay, so Y is also 4 units below. So I'm going to go 4 units above. There's Y prime. And Z is 2, 4, 6 units below. So I'm going to go 6 units above. And there's Z prime. So we're going to connect all of our dots. And it makes a rhombus. All right, so W prime is -2, 4. X prime is 1, 2. Y prime is 4, 4. And Z prime is 1, 6. So once again, my Y values changed signs, but all my X values stayed the same. Okay? All right, so moving on, now we're going to mix things up a little bit. I still have all the figures drawn for you guys, but now we're going to throw in some actual lines. So we're not just talking about axes anymore, we're talking about real lines. So the first 4 are all going to be lines that are going to be either vertical or horizontal. This first one is an x equals 4, and so since it's an x equals, this is going to be a vertical line. Okay, so I'm going to grab my line tool, and x equals 4 is going to go through the point where x is 4. And so looking at my graph, x is 4 at this point right here. And so I'm going to draw a nice vertical line that goes right through that point. Now we're going to go in and we're going to do the same thing that we did before. So K is 2 boxes to the left of that yellow line. So now I'm going to go 2 boxes to the right, and there's K prime. J was 1, 2, 3 boxes to the left. So I'm going to go 3 boxes to the right, and there's J prime. L was 1 box to the left. I'm going to go 1 box to the right, and there's L prime. And now I'm just going to connect everything. And we're going to write down what our new points are. So J prime is going to be 7, -1. K prime is 6, 3. And L prime is 5, -2. And once again, this is going to be kind of that similar pattern that in this case, you would expect for those like X values to stay the same, but they're not, or sorry, the Y values to stay the same because it's a vertical line, but we're not going to really see that pattern. And the reason why is because we're not reflecting across something that's completely symmetrical. Okay, X equals 4 is definitely going to change your numbers in both your coordinates. But again, if this were a completely symmetrical graph, then yes, it would look the same. But it's not really going to whenever you throw in like an X equals 4, or like we're going to see in a little bit, a Y equals 2. Your numbers are going to change. However, you can probably still notice the same things with your signs. All right, so next we're going to reflect a square, and we're going to reflect it across Y equals -1. Sorry guys, sometimes this thing can be kind of slow. So X equals -1. I'm not sure if I said X equals or Y equals, but it's X equals -1. So this is also going to be a vertical line. We're going to set it up pretty much the same way. Since X is equal to -1 at this point, I'm going to have a vertical line going through that point. So there we are. And now we're just going to go in and reflect. All right, so R is, and be careful because a lot of people still get stuck and they want to use the axis, especially since the y-axis is really close here. Make sure you're always referencing the actual line. And actually, I might change that color for this one because you might be able to see it a little bit better or bring a little bit more attention to it. So let me change that. I'm going to make it red just so that it really stands out. So we're looking at that line. Okay, so make sure that everything that we do is referencing that one. So r is 1 unit to the right, so I'm going to go 1 unit to the left, and that's going to be r prime. S is 1, 2, 3, 4, 5, 6 to the right, so I'm going to go 6 to the left of the red line, so 1, 2, 3. So about right there. T, it looks like, is 7 units to the left, so I'm going to go 7 units to the right, which would end up about right here. And there's T prime. And then U is 2 units to the right, so I'm going to go 2 units to the left of the red line. So again, these are where people start to get a little bit tripped up, just because it is, looking at a specific line. Oh, sorry, my pen shut off in the middle of that. Whoever thought to put like the on-off button on the side of the pen where you write? That was not a smart idea. Okay, so R prime is negative 2, 3. S prime is negative 7, 4. T prime is negative 8, negative 1. U prime is negative 3, negative 2. All right, so to keep going, now we're going to look at some y equals lines. So these are going to be horizontal. And I'm going to use red again because I think that helps. So the line y equals 2, this is going to be a horizontal line, just like I said. And so let's draw our line here. And the line y equals 2 is going to go through the point where y is 2. So it would look like this. Now we're just going to go in and make our new shape. All right, so E is 1 unit below the red line. So now I'm going to go 1 unit above, and there's E prime. F is 1, 2, 3, 4, 5, 6 units, looks like. I think I miscounted. 1, 2, 3, 4, 5. 5 units below. So now I'm going to go 5 units above. So 1, 2, 3, 4, 5. So there's F prime. O is 2 units below, so I'm going to go 2 units above. So here's O prime. I don't know why I made that a Q. It's really early still. At least in my world, it is right now. Okay, so I'm going to change this to an O so you guys aren't totally confused where a Q came from. Or that's not even an O, that's a D. Oh my gosh. I promise, it actually really is early when I'm recording this. Maybe that's why. Okay, it's a D prime. Oh, okay. So then C is 1, 2, 3, 4, 5, 6 below. So I'm going to go 6 above. So 1, 2, 3, 4, 5, 6. So there's C prime, and I'm confident that this one is actually C. All right. That's too funny. Okay. So here is my finished shape. Now let's write down what our points are. So C prime is going to be negative 4, 8. D prime, not O prime or Q prime, is negative 2, 4. E prime is 6, 3. And F prime is 4, 7. Okay, let's do one more like this. So we're going to use another horizontal line. Y equals negative 5. Alright, and so y equals negative 5 is 1, 2, 3, 4, 5. So it's going to go right here. Okay, so it's kind of cutting off the end that I made. Alright, so let's reflect across that line. So N is 1 unit below, so I'm going to go 1 unit above, and there's N prime. P is 1, 2, 3 units below, so I'm going to go 1, 2, 3 units above, and there's P prime. And M is 1, 2, 3 units below, so I'm going to go 1, 2, 3 units above, and here is M prime. Connect my dots. So that one was much faster. And now we just have to write down what our points are. All right, so for M prime, it's -6, -2. N prime is -1, -4. And P prime is -2, -2. Okay, so those are if we have horizontal or vertical lines that are not an actual axis. Now the last four that we do are going to follow completely different rules. We're still going to, draw the line, but these are kind of different because we're looking at a diagonal line. And there's really no way for you to do like the one below, one above thing that we just talked about. So what we're going to do instead is we're actually going to change the points and then graph them. So let me show you what I mean. So for the next two, we're going to be using the line, which is y equals x. I'm going to go ahead and use red again because I think that's showing up a little bit more clearly. So y equals x starts at the point 0, 0. And basically, y equals x is a function where everything that you plug in, you also get, everything you plug in for x, you get for y. So if I plug in 1 for x, I get 1 for y. If I plug in 2 for x, I get 2 for y, okay? Because they're equal. So we're really looking at a line that goes like this. Why does it keep erasing it? Okay. So it looks like that, a completely diagonal line. So let me graph that for you real quick. Okay, so that is the line y equals x. And this is why I know you might think, oh, I can still do this, but you really shouldn't attempt to. There are actually some special rules that we can go through about what to do. And I'm going to get rid of this little table real quick. Or I might actually just move it over here to this side so you guys have it for later. All right, so here's your rule for y equals x. Okay, so we're looking at, here we go, y equals x. When we're dealing with y equals x, we are just going to flip, sorry, my pen shut off. Ugh. You're gonna hear me say that so much in the next few weeks, I'm sure. You're gonna flip x and y in your points. That's basically it. That's what you want to do, and that'll get you your new points. So what I mean by that is x ended up being -5, -2 to begin with. X prime is going to be -2, -5. Okay, you following me? So then -3, 4 is going to become 4, -3. Z was -1, 1, so it's going to become 1, -1. So I'm just flip-flopping my x and my y. So that being said, let me graph those points. So I have a point at -2, -5. And this is x prime. Y prime is 4, -3. And Z prime is 1, -1. So like that one you might have been able to come up with. However, I really don't want you guys trying to do that. I've seen way too many people make huge mistakes that way. It's better to just change your points and then graph them. Okay, so that is our finished product. So we're going to do the same thing with the next one. It's going to be the same line, so I'm not going to go through how to do that again because I'm trying to make these as fast as possible. So I'm just going to draw that line for you guys. So there's the line y equals x. Once again, we're going to flip-flop our x and y. I am going to write that down. just because it's really, really, really important. So might as well write it twice, right? Okay, so G started off as 2, -1. So G prime is going to flip them and it's going to become -1, 2. H prime was 7, -1, so it's going to become -1, 7. I prime was 7, -4, it's going to become -4, 7. And J prime is going to become -4, 2, since it began as 2, -4. Now we're just going to plot those points and connect our dots. And we're going to end up with the point -1, 2, which is right here. And this is G prime. H prime is -1, 7, which is all the way up here. I prime is -4, 7, which is right here. And that one is I prime. And then -4, 2 is J prime. So this is one where, as you can see, if you were just trying to reflect it like we've been doing, you probably wouldn't be very successful, okay? Because sometimes these reflections across y equals x have some really strange end results. Okay, so that's what it looks like. And if we folded across that red line, they would match up exactly, which is why this is a reflection. Okay, now the next two are almost identical. The only thing that changes is that, well, first our line is different. It's y equals -x. And what that means is that for our x and y, they're still equal, but the x value is always the negative of whatever the y is. Okay, so if I plugged in 0, they'd both be 0. But if I plug in -1 for x, I'm going to get +1 for y. If I plug in +1 for x, I'm going to get -1 for y. Okay, they're always the opposite. Okay, so let me draw what that looks like, because it's basically the same line as before, just going in a different direction. It's going to be sloping downwards like this. Okay, so that's our line. And this time our rule is similar. We're still going to flip. Oh, sorry. I'm still on the line tool. Let me get rid of that. Okay, I'm going to flip x and y. But we also have to change the signs. So, and we're going to change the signs. So they're just going to become whatever the opposite of their starting sign is. Okay, and I'm not going to write this twice because it takes up a lot of space. So we'll use this for 11 and 12. All right, so again, you don't want to try to graph this first and then find the points. You want to find the points. So we're going to flip-flop the x and the y value. So I'm starting with a, which is -1, 3. Okay, so if I just flip-flopped them, then it would become 3, -1. However, we also have to change the signs. So it's going to become a -3, +1. Okay, let me do that for you guys one more time, and then I won't spend too much more time on it. So B is 0, 6. So if I just flip it, it's 6, 0, but now I need to change the signs. So the 6 becomes negative since it was positive, and the 0 is not going to change because 0 doesn't have a sign. Okay, so C is going to become -5, -3 following those rules, and D is going to become -2, -2. All right, so those are my points. I'm going to go plot those, and then we'll have our new picture, and then we have one more to do, and we'll be done. So -3, 1 is right here. There's A prime. -6, 0 is right here for B prime. -5, -3 is here for C prime. And my pen shut off. Go figure. Okay. And then -2, -2. is D prime. I'm gonna connect those. And it shut off again. Oh my goodness. All right, so there's my picture. And one last time, I just want to do this with you just so that you know what to do. Okay, same deal, same line with the next one. We're still going to use y equals negative x. It does not change. It looks like the same line, which is sloping like this. So we're going to flip-flop our x and y and change their signs. So -1, -6 would become -6, -1, but then I have to change both their signs. So it becomes +6, +1. T prime, flip-flop them and change their signs. So I get 3, 0. And then with u, I'm going to change it to -4, 3, but then I have to change their signs. So they become 4, -3. I'm going to plot those real quick. So here's S prime. T prime is 3, 0. Cool, I already had that. And then U prime is 4, -3, which is right here. So it's kind of overlapping a little bit. Okay, so the shape is going to look something like this. All right, so there's our reflection, and that pretty much covers every single thing that you could possibly see. So if you guys have any questions, make sure that you're talking to me on Remind, and I'll try to explain things that way. I'm also trying to figure out a way for us to do like a video conference if you guys need it. But if you have any questions, please let me know. If you have any issues with using IXL, also let me know. Okay? Well, I will see you guys later. Well, not actually see you guys later, but I will talk to you guys later. And I hope that you guys stay healthy, stay well,